Good afternoon, everybody. Thank you for coming to my session. This is going to be a discussion of our wireless implementation, especially focusing on security. And my name is Rezi Andoni. I am with the IT department here at Cisco College of Law. The audience for this presentation is going to be the infrastructure people who take care of the routers and the switches and the wireless, and network administrators, people that give access, create accounts, and the technical level is medium to high. And what I'd like to do during my presentation is I'd like to make a call in time after time when I mention something. So if you have the same thing to your organization, you probably can watch who raises the hand and get together after the presentation, maybe tomorrow, and talk in more detail of specific issues you're having. This is a brief introduction of Kent. Of course, like pretty much every other law school, we require students to have laptops. We have around 1,200 laptops together with our business school. We use Active Directory to centrally authenticate users. And the computers were joined to a domain at some point. So each student laptop is a member of the domain. Each computer has a computer account in the domain. And as I'm seeing differently from other law schools, we manage our own infrastructure here. So we are independent from our main campus as far as infrastructure. Any other law school has independent infrastructure that it manages themselves? Okay, like 40% of the audience. The requirements for our wireless network were users need to authenticate. So not anybody can access the wireless network. Wireless traffic must be encrypted. We are in a very heavy business environment here. I can tell you something. If you take a very good antenna and go to the window, you will see at least 200 system IDs. It's so busy. It's unbelievable. You can connect to, like, with a good antenna, you can connect to about 30 of those. Browse the internet, have fun. So encryption was very important for us. We, of course, need to use our existing Active Directory to authenticate the wireless users. We needed seamless integration. With 1,200 laptops, having our help desk involved, and especially with the evening students, our help desk is not here when they come to take classes here. That was a huge task. Of course, the ability to accommodate guests, no or little overhead on our help desk, as I mentioned. And of course, every IT department likes this, not to add additional vendors. So if you use Cisco or Microsoft, you'd like to stay with Cisco and Microsoft and not introduce additional vendors. And of course, ease of implementation. Now, choosing the security strategy. The first option is wireless is not secure, do not deploy a wireless LAN. The other is make an unsecured wireless LAN. You make it available to your users. You say to them, it's not encrypted, use it on your own. The other one is static web security, where like you have in your home, you give the encryption key to everybody, and everybody enters the encryption key. The problem with that is that this is easy to break the key, and it's difficult to maintain this kind of infrastructure. The other is to authenticate the users using their MAC addresses. Okay? This offers no encryption on the air. Everybody can sniff the air and see what traffic is going on the air, and it's easy to sniff the MAC addresses and spoof them, so everybody can break this kind of security. The other option is to use no security on the wireless side and require a VPN for encryption. A lot of places are doing it. Is anybody doing this using no encryption? What's number 5? So this, and actually the Vanderbilt Law School, they had a close implementation. They had a VPN concentrator, but they were not doing any encryption on it. They were just using it for authentication. So that's pretty much similar. So you need a VPN concentrator, which can constitute a bottleneck, because everything has to go through the concentrator. You, in some cases, will need additional software on the client, because sometimes the Microsoft VPN client is not enough for that. Might be more costly than an EAP solution. I'll talk later about EAP. And client computers can be attacked individually. Somebody else can connect to the SID, and if the client computers do not have a personal firewall, they can be attacked, or if they're not patched. So this does not offer a protection for the client itself. And in most cases, the user has to start the connection. It's not automatic. I mean, a lot of implementation, this is automatic, but sometimes it's not. The other possibility is to use an IPsec solution. There is a session tomorrow about IPsec. Is there anybody here that is going to present it? No, it's not here. So probably if you want to know more about an IPsec solution, probably the session tomorrow will be the choice for you. This needs a certificate infrastructure. So you need, in most cases, you will need certificates distributed on all your laptops, which a lot of places do not do. And I don't know any place that really does that, because that's so difficult to maintain that kind of infrastructure. And this will encrypt the traffic between the client and the server. Let's say we have Windows XP and Windows 2000 for servers, but you need the router as well to terminate an IPsec session for this. So this can be a significant overhead. And this might result very difficult to maintain this kind of solution. And the protection on this solution happens on the network layer, on the IP layer, not on the data link. Okay? Anybody using IPsec within client server IPsec? As I expected, nobody's using that. Now, let's move to another solution. Now, before I go any further, anybody using PEAP already? No. You? Anybody using LEAP? Just one. So the first solution is LEAP. It's proprietary technology from Cisco. For this, you'll need extra cost. You have to purchase the Cisco access control server, and you are bound to a proprietary technology. Okay, so you can't introduce like handheld devices or anything like that. You have to buy everything from Cisco. And everybody knows Cisco is kind of pricey. The other one is EAP TLS. This stands for transport layer security. This is supported by Windows XP clients, but this technology is already in anybody doing EAP TLS? No. If this goes back to an IPsec solution, you need a certificate infrastructure for this kind of technology to be implemented. you need certificates on the desktop computers in order to do something like this. And needs, as I said, a public infrastructure. Now we are, the EAP, TTLS, and PEAP are both at the moment internet drafts. So they are going through the IETF internet standard. So there are a lot of other, IETF needs to hear from a lot of people that it's a good technology before it makes it a standard. And of course, there are a lot of other EAP standards. Now, let's go to the encryption. Everybody pretty much familiar with WPA and WPA2? Yeah. So the problem with these new encryption technologies is that the older wireless LAN NIC cards do not support this kind of encryption. So if you want to introduce this kind of encryption, you have to ask your students, you have to go and buy new NIC cards. This is pretty much for the students who came here like 3 years ago and they do not have the newer NIC cards. As well, the WPA2 needs firmware on the access points upgrades. So the choices left for us after this elimination process were PEAP from Microsoft and EAP TTLS, Tunneled Transport Layer Security. PEAP is an internet standard proposed by Microsoft, Cisco, and RSA. TTLS is an internet draft by Funk and House. At the moment, they are both drafts. The client software, PEAP, Microsoft gives PEAP with XP. With TTLS, you have to purchase the client software. The protocol structure is pretty much the same, and the authentication process that happens between the client and the radio server is very good encrypted in both cases. Protection of user identity is very good in both cases. And when you come to additional software, PEAP, if you have a Windows 2000, 2003 infrastructure, the Microsoft IAS Server, Internet Applications Service that comes with Windows 2003 and 2000, it already supports PEAP. And the Windows XP client, it already has the PEAP client in it. So you don't need any extra software if you're going with a PEAP solution. But with TTLS, you of course do, yes?
What about Mac?
Mac is adding support for PEAP, and the newer versions have support for PEAP. The very latest versions. I had a student coming with, we do not officially support Mac here, but I had a student coming and I was able to help. Now, let's go to the checklist about PEAP. First, we needed the Windows 2003 domain controllers, which we have, and I believe every law school is 2003. Active Directory pretty much. Anybody not using Active Directory in law schools? So like 20% of the audience don't have Active Directory. Okay, do you have any centralized authentication? Yeah.
We have LDAP.
LDAP. Okay, so LDAP is fine. Okay. The other is the Microsoft Internet Authentication Service, which comes with Windows 2003. So it's a service that comes with that. And PEAP is a technology that needs a certificate on the server. Does not need the certificate on the client, but the radio server needs a certificate. And I'll go later on talking about it. Of course, the access points. We, like everybody else, I believe we have Cisco. Anybody not using Cisco? Just one. So pretty much is using everybody Cisco access points. Windows, all our clients are Windows XP, and of course Service Pack 1 or Service Pack, I believe everybody is Service Pack 2 at this point. And group policy. Group policy is a component of the Windows 2000 Active Directory. So if you have Active Directory, you have group policy. Everybody using group policy for some purpose? No? Okay. It's a very good component of Windows 2000, 2003 Active Directory. I mean, it really makes your life very, very easy. And of course, and the optional components for this solution were a management device, a device that will control all the access points in one place, so you don't have to go to each access point to upgrade the firmware, change the password, and do a change. You do it from one point. And there's another technology, Cisco WLSE, which I'll have a couple of slides at the end just to give you an introduction about the technology. So the overall picture is you have the client, which goes to the access point. The access point relays all the conversation to a radio server, and the radio server, once it receives a username and password, goes to Active Directory and says, does this user exist? Okay? And if so, often it says to the client, yes, go ahead. I mean, it says to the access point, this client can use your service. Of course, you have the primary radio server. You can have a backup in case the primary fails. And on the Active Directory side, you'll have a backup domain controller in case of one of those has. Actually, in 2000, 2003, that primary and backup concept doesn't exist anymore. And you need a certificate on the radio server. Okay, the radio server needs a certificate, and the client needs to trust that certificate. Okay, needs to trust the authority that issued the certificate for the radio server. It's like when you go to a website to your bank, the bank web server has a certificate, and the client trusts that certificate because it was issued by VeriSign. And when you go to your certificates in your local computer, you have the public key of VeriSign. Okay, all those trusted authorities. So that's why you don't get a warning when you go to your bank account, but you get a warning when you go to some website who has a certificate that the computer doesn't trust. In this case, you need the client to trust the authority that gave the certificate to the radio server. Now, this slide talks about the ways to get a certificate for your radio server. You can get, of course, a certificate from an online authority, VeriSign. There are so many. The con for this is that this is a little additional cost for this solution. I mean, you have to pay for each radio server you have to pay, I don't know how much it is, around $300 for 2 years or something like that. The pros are that the client computers trust VeriSign. They trust all the online authorities because when Microsoft shipped Windows XP, it put those certificates with the operating system, those public keys of these trusted publishers. The other choice for a certificate for your radio server is to make your own. And you can make your own certificate authority by using the Microsoft certificate services, or you can do. We have implemented the Microsoft certificate services. Anybody else using Microsoft certificate services for any purpose? Just one, two. So you can do this. You can use this for other servers. So if you have other intranet servers here, at your school, you can create certificates for your web servers, as many as you can. And the propagation of the client to the client computers is pretty much automatic. Microsoft takes care of that. The cons for this is that you have one more service to maintain and need some understanding of the public key infrastructure. The other solution for a certificate for your radio server is to use free software, OpenSSL. Anybody using OpenSSL for anything? 2, 3. So it's free and of course it can be used for so many other purposes other than authenticating your wireless users. The cons for this is that once you generate a certificate for the root certification authority, you need a way to take this certificate to all your clients so they can trust the authority that gave the certificate. This can be a process that can be automated in so many ways. Send an email, download this file, and here there are 3-4 steps to install the certificate in your home computer. This is our experience with Microsoft Certificate Services. It comes with Windows. If you integrate the certificate server with Active Directory, the request and installation of the certificates is very easy, seamless with the wizards that Microsoft is famous for. And the authority is the process that I said is difficult with OpenSSL is automatic with Microsoft Certificate Services. That means that you don't need to do anything to the clients for the clients to trust the authority that you just created. The next time they log on, it comes through Active Directory and it gets installed automatically to the certificate store in the client computers. Yeah, it's this is what I just said. So if you don't want to have 2 boxes for this, one for the Windows server, one for the certificate server, you can easily put both services in one machine. Okay? These are the steps that you will need to do in case that you decide to go with a solution like this, and maybe you'll try this in your lab first. You have to install one more domain member, install the certificate services integrated with Active Directory. From the radio server, using the certificate wizard, you will request a certificate. Anybody's familiar with the local certificate snap-in management console? Yeah. Once you make a request from the radio server, you'll go to the certificate server and right-click and say approve. The approval process is just one click. And you install the certificate on your radio server. And then it's a good idea to firewall that certificate server. So your students, probably somebody will play, let's play with the encrypted file system. When you try to play on XP with the encrypted file system, XP will automatically go to a certificate authority within the Active Directory and request a certificate for the client. In order to block this kind of stuff, probably there are other ways to do this, but one way is to firewall to put a personal firewall on the certificate server. Okay? Now I'm gonna move to the Internet Authentication Service. Anybody's using the Microsoft Radio Server for anything? One, okay. So the first step is you add your access points. And to add an access point, you just will need the IP address of the access point and a password. So we'll add the IP and a password, and that's all you do. If you have a switched environment where it's not possible to sniff the wire, you can use very easy passwords. There's nothing that will prevent you to use an easy password. And of course, in this previous screen, you have to choose an AP vendor. The other thing is configure the radio server logging. So it depends on how much logins do you want to receive. You can log in 3 places. You can log in a flat file, comma limited. You can log into a simple server, and you can log on Windows Event Viewer. And you'll see here to try to authenticate and so on and so forth. The other thing is you have on the radio server you have to configure a policy. So I made this presentation kind of a tutorial too. So in case you want to try the same thing, you can use the slides to try. You have to create a policy. Okay. Currently we have 2 policies. One that controls the wireless access and another that controls VPN access. So you can use one radio server for two purposes. And the policy that gets the most hits has to be listed first, okay? Because we have far more wireless users than we do have VPN users. So in order to configure the wireless policy, generally you have to put two policy conditions. One is that the first condition is telling the wireless server, the radio server, that the request comes from the wireless device, and this is what you see here: NAT port type matches wireless, etc. And of course, the second policy condition is somebody to be authenticated through this policy. He has to be a member of a certain group, and this is where more the role of a network administrator comes. So you have a group, and all the objects. It can be a computer, or it can be a user. You make the objects that need access member of this group. Okay, and in our case, the group is named wireless users. Okay. The other step that you do on the radio server is you have to configure the so-called EAP methods. EAP stands for Extensive Authentication Protocol. And under the EAP types, you have to add PEAP. And of course, any other, if you choose not to implement PEAP, of course you can choose other EAP methods. Now, what will this solution do? This will give the client an automatically generated web key. So the encryption will still be web. And anybody has tried to crack a web key with a tool like a web crack or anything like that? You have tried? Okay, so just one. So it is. I mean, with the amount of, so it is possible to crack a web key. So the way to make that web encryption better is to change that web key every, let's say, 60 minutes. Now, where does that 60 minutes come from? There is a white paper out there telling that for somebody to crack a web key, he needs more than 1 million packets. Okay? So what you're doing with the 60 minutes, you are telling, you do an estimate saying that doing normal stuff, browsing the web, checking your mail, doing your instant messaging, downloading some music and so on, you cannot have more than 1 million packets in 1 hour. Okay? Somebody, of course, watching a movie over the net can have more than 1 million packets, but it's a good estimate that a user will not have more than 1 million packets. So by telling the radio server to re-authenticate the users every 60 minutes, you are, I would say, 100% sure that nobody will have a tool to crack that web key. Okay? Of course, telling the radio server to try to re-authenticate users every 1 hour puts a little overhead on the radio server, but I've been monitoring the processor use and everything on our radio server, and no issues at all. And of course, for higher security environments, you can make the timeout 15 minutes or 3 minutes. But I believe for a law school, 60 minutes is more than enough. I would say even 3 hours would be fine, because our students just do most of the time web and stuff. Now, fast reconnect. Fast reconnect is a way to tell the access points when a user moves from one access point to the other, do not go through the whole conversation to authenticate yourself. If the radio server has a session ID for you, by saying to the radio server enable fast reconnect, the authentication process will be much faster. This is the whole purpose of fast reconnect. And the authentication method that we have here is MS Chat version 2. in order to use usernames and password for authentication. So once you have that radio server, it's a good idea to secure that machine. So what you can do to secure the machine itself is to enable a personal firewall on the machine. And actually, the only things that you need to open on that personal firewall are just 3 ports. You'll need a port for accounting, a port for authentication, and a port to administer the box itself, so you can go to the box. In our case, we just have 1645 and 1646 UDP ports that are open, and of course another port to administer the box. Okay. Anybody is using Windows firewall to secure servers? The firewall that comes with Microsoft Windows. Okay, just one. So, I mean, if you try in a lab and you see that the services are not affected by the personal firewall, I mean, why not? Make the box more secure. Now, going to configuring the access points for the people here that manage their own infrastructure. The access points are not. I'll go through a couple of slides later. We'll show why the access points are not aware of the EAP method that the client uses to authenticate to the radio server. Maybe LEAP, it may be PEAP, there are so many EAP methods actually. Of course, you need to change your default SNMP communities and default passwords. And the steps usually to configure EAP is you define a SID, you require EAP authentication for that SID, you require mandatory web encryption, and you add a radio server. So pretty much it does the 4 steps that you do to configure your wireless access point. Or actually, all Cisco access points have little wizards that you can do all this in a wizard. Load balancing and redundancy between the APs and the radio server. So if your radio server dies, none of your users will be able to authenticate. So it's a good idea to have 2 radio servers. And you have half of your access points configured to use radius 1 as primary and radius 2 as secondary. And the other half using radius 2 as primary and radius 1 as secondary. This is a good technique for load balancing. This is a good technique for redundancy. Okay. Okay, this is exactly what I just said. Now the issue comes on configuring the client computers. One way to do it is send an email with instructions. Do this, do that, which is not elegant and can be hard to be followed by certain users. You can create a web application that will modify the registry on the. I mean, you can be an ActiveX control or something like that on an executable. When you execute it, it will modify the registry properly. Or if you have Windows 2003 domain controllers, or at least one domain controller would be a 2003 server. You can use some group policy extensions that Microsoft has introduced in 2003. And those are to configure automatically the client computers. Anybody has seen this screen before on group policy, especially on here, on this, on the wireless network? Okay, so probably nobody has played with it yet. So what this does is, okay, wow. What this does is, this will configure all your clients right away. You don't have to do any manual step at all. Okay. So, and to configure this group policy on your domain, first you have to add a SID. In our case, the SID is Kent. Okay. So these slides, these 3 or 4 slides that I have, the whole purpose of group policy on 2003 domain is to configure the clients properly. So all those steps that you did today, not today, but yesterday on adding the Kent SID to your computer, our users, since they are a member of the domain, they don't have to do. Okay, and the tool to do that is 2003 Active Directory. Okay, and if you're real concerned about security, you have to where's my mouse? You have to under the certificate servers, you have to choose your radio server as the machine that gave the certificate for the radio server. So this is the way the client authenticates the radio server, because you can have, I mean, with the existing wireless authentication technologies, you can have somebody staying on the parking lot and having an access point with the same SID that you have and saying, hey, authenticate everybody that comes to me. Okay, and all the traffic will go through that access point, and they can sniff the traffic and do whatever with it. But if the client authenticates the server, then this is not possible. Okay? So, and the way to do this is under letting the client know which certificate authority gave the certificate for the radio server. Okay? So what will group policy do? Under the preferred networks in Windows XP, it will add a SID on the preferred networks. You can apply it to the whole Active Directory, or you can apply it on certain organization units. The users cannot play around with the preferred network. So once the preferred network is entered once the SID is entered under the preferred networks, the user cannot remove it anymore. Okay, but of course they can add other SIDs that they have for home use or for wherever they use wireless. And if you make a change on the group policy, it will automatically be updated everywhere. So what we were able to do with these technologies that I described so far is and so fast maybe, I'm sorry, is when we announced the wireless network to our students, we said that, hey, the wireless is there and you don't have to do nothing. So once the students read the email that the wireless is available, they can easily unplug the wired connection and be on the wireless right away. So there were no steps that our students had to do for this. And this was very important for our gifting students that we don't see at all. Now there are some login script issues here. We do use login scripts for our students to map network drives and to do other stuff on the student computer. If you have seen Windows XP prints that if you have a fast computer, it prints the login screen right away, and you can log in with your cache credentials. And in order to avoid this, is to send an email to your students saying that if you want your login script executed, just wait 10 or 15 seconds on that login screen. Don't go right away, because at that time your computer will be authenticated and connected to the wireless. And after you log in, you'll have your login script and everything. Or there's a policy with Microsoft that tells the computer, do not bring that login screen right away. Wait for your network connections to be ready before bringing the login screen. This is not a problem if the wireless signal is good everywhere, or there is no signal at all. But if you are in an area where the signal is not very good, then this is not a good solution. The client will stay trying to re-authenticate over and over. Now, to give an understanding of PEAP and why it's a very secure way to authenticate users, PEAP actually has two phases. Phase one is to create a TLS channel. Creating the TLS channel is like the first time you go to your bank and creating the SSL tunnel, okay, with the bank website. The phase number 2 is to send your credentials over this created secure channel. Okay? So PEAP, probably this slide had to be before that one. What an EAP method is, EAP actually consists of three building blocks. One is the supplicant, which is the client. The other is the authenticator, which is the access point. It can be a switch if you want to control access to your wired connection as well, and an authentication server, which in most cases is a Rezi server. And what the whole process consists is telling the authenticator whether to allow or not a client. So this is an EAP is an RFC, is an internet standard, and there are a lot of technologies built on EAP, and PEAP is one of them. Okay? And this is kind of I don't have the time to talk about this, but on part 1, all you do is you create an SSL tunnel. The client creates an SSL tunnel with the radio server. And the beauty of EAP is that the access point or the switch is not aware of what the client is talking with the radio server. It just takes one message from the client, translates it into some other form, and sends it to the radio server. That's all the access point will do. That's the reason I said that the access point is not aware of the kind of EAP implementation that we have. Okay? At the very end, after all these messages that I've described here, if the radio server tells the access point that this client is authenticated, sends a message, and will send a keying material. When I say key material, I didn't say the key, but key material. It is important to say that the authentication method that takes care for authenticating is independent from the encryption method. So the access point will take the key material, and based on formulas that are described in the internet graph, will create a key. So if you are using web, it will create a web key. If you are using TKIP, it will create a TKIP key. If you're using AES or DES, it will create the appropriate key. So it all tells, here's a string that I'm giving to you. Based on the formulas we have, we create a key for each client that needs to authenticate. So it's a very, very secure method, and it's very hard to break. Now, I'll go in our solution that we chose to manage our access points. So what we need to do is receive faults from the access points, configure the access points in bulk, and of course apply standard configuration to newly added access points, update the firmware when new firmware becomes available, create reports on clients, manage inventory, and of course tune the RF parameters of the access point, transmit power, etc. Our choice was for WLSE. Anybody using WLSE? So, well, I mean, it's a very convenient solution if you want to do everything in one place and don't have to go to each access point. With 40 access points, it's a problem.
Does that work with Cisco here, or does it work with other?
That's just for Cisco. That's just for Cisco access points. Of course, more information about the WLSE will have the Cisco website. I'm not going to do any marketing for them here. But it gives plenty of configuration options, and it's another technology called WDS for better reporting. So you get better reporting when the client authenticated, gives historical association for the client. So you'll have, let's say, Rezi authenticated, use the wireless at this moment, connected to the first floor east I mean, this kind of reports, historical association. This WDS technology, this is good if it's more useful for hospitals where they have Wi-Fi phones, 802.11 phones for nurses and everything, and they need, when you roam from one access point to the other, you need to have the voice stream. You don't need to have that lag when you move from one access point to the other. You know? But this is not. I believe this is not an issue for any law school, because you can't tolerate some packet loss when you go from one access point to the other. But the technology is there. If you are concerned about it, you can implement WDS. We implemented WDS in the beginning, but now we don't use it because we really don't need it. So if you implement the WDS, it adds one more component on the first picture that I made. So the client has to go to the access point, and the access point has to go to WDS server, and WDS server has to go to the radio server. And you add all this complexity for faster roaming from one access point to the other, and to have some better reporting in the management device. But since nobody is using it, I'm not going to spend any too much time on this. So I'm going to skip this slide. And guest access with this solution. One way is to create an account for each guest, and this is convenient when you have few guests. You can create one shared account and give an instruction sheet, and hopefully Microsoft will come with some software that will do the steps that some of you had to do 1 to 9 to make connection to the wireless network more convenient and faster. And the other solution is to create a guest VLAN. Okay, and let's say you have the Kent SID for your students, faculty, and staff, and you have a VLAN named guest. I mean a SID named guest, which actually goes to a separate VLAN, and that doesn't need to be encrypted or authenticated or anything. It can be opened up. Currently, Cisco has that possibility, so you can create your guest VLAN. And the guest VLAN actually needs some extra configuration on the firewall or on the router to create another VLAN. And you have to give IPs to that and probably do some network address translation. And in order to turn the guest VLAN on and off, with the device that we have, it's kind of easy because you will create a job that will create the SID and delete the SID to all the access points. Or you can shut down a firewall port or a router port that connects the guest VLAN. Or if you use VTP, which is a Cisco technology, you can change that state to suspend it in your service switch. And here are some references. The internet draft is there. That's more for companies that want to implement PEAP and make products that work with PEAP. There is, if you search in Microsoft.com, securing wireless LANs with PEAP, there's a very good document that Microsoft has over there. About group policy, Microsoft has very good resources in its website. And of course, there's plenty of documentation regarding the Internet Authentication Service that comes with Windows 2003 and 2000. The slides are going to be online, so everything will be available. And any questions? So everybody will keep their own infrastructure. Nobody's going to move to PEAP. That's what I think. It's too complex or what? Okay. Thank you, everybody.